All right, if you're looking for Calculus 1, Spring 2017, Lesson 9, you're in the right place. And to start Lesson 9, I guess there's all kinds of stuff in it. It is all related somehow, but to start with, let's consider the question of what it would take for f prime to ever be undefined. Okay? And here's the scenario. You have some kind of a curve, y is equal to f of x, and at certain spots, under certain conditions, the derivative could be undefined. So the first one, if the curve had a corner point, and I'm not going to describe a corner point other than to say that that's a corner point. I would say it's undefined at a corner point because if that's truly a corner, it doesn't matter how close you look. You just see more of the corner. Okay? Analogy. We first started this in Lesson 8 at some point. I would have said, well, a curve is obviously curved, but if you look close enough at any one piece of it, it looks straight. And so therefore it has a slope point for point. Okay? But if that really is a corner, then it doesn't matter how close I look. You just see more of a corner. It never smooths out into a line no matter how close you look. And so the derivative, because it would tell you the slope at that spot, would have to be undefined if it's a corner point. Okay. Now, that's no math there. That's just an intuitive reason why f prime is undefined at a corner point. There's no slope that there could possibly be at the corner. All right, now an easier one to accept is if the curve was ever vertical. So here's any random curve, and at that little section right there, at that point, it is straight up and down. It's vertical. And a vertical line has an undefined slope, and if the derivative tells you the slope of the curve, then the derivative would have to be undefined at that one spot. Only at that spot, right there where it's vertical. Okay, so that's the second case. Third case, maybe more obvious than the other two. If the curve had any kind of discontinuity, then, well, there can't be a slope there. Okay, like at that spot, at that point, given that it's broken off from the rest of the curve, there's no way for me to measure the slope at, say, 3, if 3 is where the discontinuity happens. All right, now, so those are just scenarios that we're going to have to accept. Next thing, okay, let's take that to the next level. So this would be in Lesson 9, Question 4, and I'm given an original curve or function only by graph. There's no equation for it or anything like that. And in Question 4, it says, what is f prime, and then could you draw the graph of f prime? Okay, so I guess, all those rules that we learned can't work over here because I don't even have an equation for what that is. I guess I would just have to think about what kind of information is f prime supposed to give you about f. And for me to give you a correct answer about f prime would be something that told me the slope at every point of this, because that's what the derivative does. One of the things it does, it tells you the slope of the curve. Okay, so I'd see this curve, the way it is broken into 3 lines. And I don't know, how about this in red ink? I'll do my math. Like that piece right there is horizontal on the graph. Okay. So the slope 0 entirely there. So f prime, whatever the answer to that is going to have to tell me that f prime is 0 out there. What about this other piece? Right there. Well, that's by itself a line, a little piece of a line. And the slope there, given that it goes between this point and that point, is, well, here's how you find slope of a line. There's the rise. There's the run. So 7 over 2. At every single spot from 3 to 5, the slope is 7 over 2. Okay, so the derivative is going to have to tell me that, because that's the truth. And then this last piece over here, from negative infinity over to 3 on the x-axis. Well, the slope there, given that that is a line that happens to have these points on it, 1 minus negative 2, that's going to be 3, over negative 1 minus negative 3. It's going to be negative 4. So negative 3/4, okay? All right, now, so I've completely described the slope of this thing at every spot. F prime will tell me that information. I mean, how would you get that across? I guess like this. Let's say F prime, your derivative, depends on the x. Let's say if x is from negative infinity over to there, 3, it's negative 3/4. Okay? So let's say, I don't know, let's just say x less than 3. Okay? And then from 3 to 5, the slope is continuously 7 over 2 everywhere. So f prime would have to be 7 over 2 for any point where x is between 3 and 5. And then last, f prime is 0 from 5 onward. So we'll say 0 if x greater than 5. Well, that's it. That's simple. Somebody says, why is that right? Well, it does tell you the correct slope all the way through that graph at every single point. Do we need to read the fine print? Well, what's the slope of this graph at 5? Well, that's a corner. We can look as close as we want to that spot. It will never smooth out into a line that has a slope. That's a corner point. This is a corner point. There is no slope. No way to measure the slope of those points. So notice, didn't that leave off 3? It also left off 5. So let's not miss this. I mean, I give you the answer. There's the answer, but don't miss the fact that f prime of 3, according to this definition, and f prime of 5 are both undefined. Why? Well, because that's the nature of the curve. You have corner points at 3 and 5, and there's no way to have a slope there. Okay, so in parentheses I'll put corner points. That's what corner points are. Okay, so it says to draw the graph. All right, so let's do that here, and then we'll see the original curve here and the derivative there. It's not very hard to draw the graph of this. I mean, you get 3/4 here, you get 7 over 2 there. So I'll put this. We'll say let's say that's 3 and that's 5. It doesn't have to be to scale, okay? So if you're less than 3, f prime, what you get out of that's negative 3/4. So we could like say put an open point there and then like that, okay? Well, we're going to say, even though this isn't to scale, that's a negative 0.75. Okay, that's where that horizontal line is. But from 3 to 5, you're 7 over 2. That's 3.5 or so. Okay, so then you're up here. And where's that number? 7 over 2 right there. And then from 5 onward, you're at 0. Well, 0 would put me like right on top of the x-axis, so like I'll just do like that. It gets the same information across. Let's say here's the x-axis. The same x-axis is over there, but what are the y-coordinates if I'm graphing this? The y-coordinates are f prime. So f prime is negative 0.75. In that case, 3.5, and then 0. All right. Okay, so there's the graph. The function, the equation, and the graph, they're all the same thing anyway. So look at this, same information. All right? Okay, now that's all f prime would need to do. It tells me the slope of this original curve. However you're going to do the math, that's what it tells you. And this gives you that information. Now, how would this be any different? that is not too much different than this. It's one line and another line, okay? Joining at 3, okay? What's 3 give you there? 2 times 3 is 6 plus 1 is 7. What's 3 give you here? 3 plus 4 is 7. So it's kind of like that. All right, if you want to, we can draw a picture. If you're visual, then here's what I'm saying we got. Here's 3. And we get x plus 4 if x is less than 3. So that's going to take us up here to 7. And it's going to be open the way it is. Okay? And then that one picks up at this spot, like I was saying, because if x is 3, y will be 7. All right, I put it there. And then this is another line with a little bit steeper slope, and it looks like that. Okay, so there's y as a function of x right there. Now, when I draw it that way, you treat it like this other one. But we don't have to really do any calculations to find the slope. What's the slope of that piece? Well, how did I draw that? That was the line 2x plus 1 from 3 onward. The slope is just 2. And what's the slope of this piece? Well, that's 1, because that's from x plus 4 if x is less than 3. Well, that's all you need. So let's do like this. I have my original function. I have its graph, if you want to see it. Find y prime. All right, well, here goes. Y prime is, well, it will be 1 if x is less than 3. It will be 2 if x is more than 3. There's my answer. Why did I leave out 3? 3's not left out there. Why did I leave it out here? Well, that would be a corner point on a graph where two lines of different slopes meet. That's what a corner point is. Okay, so I could say the same thing I did up there. 3 is a corner point. The derivative gives you no answer or no information at 3. Okay, it's implied there in the definition that 3 does not give you anything because it's a corner point and there's no slope. All right. So let's do one more. That's 5a from lesson 9 and 5d. Would that be any different? Well, at this point, I wouldn't be surprised if you could look at that and you can tell me what y prime is just by looking at it. If you want something more to think about, I suppose we could draw the graph. So y is solidly 1 if x is less than 3. So in other words, we get something like this. That point would have to be open, right? Yeah, that'd be open. You don't actually get 1 when x is 3. Okay, so there you go. And then there we pick up 3 is defined, 3 goes in, 4 minus 3 is 1. This point gets included. But that is a line of negative slope from there. You could plot some points if you wanted to, etc. And you'll find that it looks like that. Okay, so here's the equation for the function, and here's the graph. All right, I think between this and this, we've got all the information. That's horizontal, slope 0. This, well, it came from 4 minus x, whether you plotted points or whatever, the slope is -1. Okay, and then we have a corner point at 3. That should be easy. Y prime is, okay, 0 if x is less than 3, and then -1 if x is more than 3. There's your derivative. I don't know. Didn't do anything special besides realize that it's supposed to tell me the slope of the curve. I know at this point somebody could say, well, do you just take the derivative of those one at a time? Like, okay, fine. Derivative of a constant is 0. Derivative of 4 minus x is -1. But I did explain all this starting with that one with some unknown function only given by a graph. Okay, so I explained these the same way, but as long as you realize that those two things connect here at a corner, these are their slopes otherwise, the 3 should be left out because the derivative is undefined there, well then you've got the whole story, okay? All right, well that's how we get started. That's, to be honest, that's the easy stuff. Something a little harder. Well, there is, I guess, the element of proof that f prime is undefined at a corner point. I'm sure everybody will be happy enough with just instinct that if that is a corner and two lines of different slopes meet there, no matter how microscopically close you look at that corner, you just see more of the corner. It never looks straight. It never looks like it has a slope no matter how close you look. All right, well, that's a matter of instinct. What would prove that? Well, in the lesson, I have question 1 and 2 that serve as a proof or a more sophisticated look at the math, okay? So we'll go through it one part at a time and we'll connect the dots from there. So say I give you y is equal to absolute value of x. That's our original curve. And here's the graph, which you could produce by memory or you could plot some points, but there it is. First part of question 1 is it says, can you make that a piecewise function? Or how could that be a piecewise function? Well, is this thing not two lines of different slopes meeting there? Yeah, so like, you know, that piece, that's a line all by itself. How? It's the line y is equal to x. That's what that is. That's its equation. And is that different than this? Yes, but you know, just that piece is what I was talking about. That's y is equal to x. This other piece, okay, that is y is equal to negative x. Matter of fact, the equation of the line that goes through this point and that point is y equals negative x. Now, I think that would do it then. This graph over there, composed of the two lines, is y is equal to x if x is positive. Y is equal to negative x if x is negative. Okay. Now we were just doing some problems and I left that part out of my answer. Okay, so you remember that? Yeah, I left that part out. Why? Well, because that was the derivative. The derivative because of the corners. Undefined at 3 and 5. That 3 and 5 have to be left out of the definition. Okay. But here I'm just, you know, this function with those points on it, that's all I'm trying to capture. That's that's not f prime. So I need to include that spot. It's got to be over here. As it is, the 0 is left out, and that wouldn't be right. So we can include it either way. And either way you do it, y will be 0 if x is 0, and you get that point. There you got all the points then. Okay, there's the piecewise function. All right, now I had told you that this is a proof that the derivative is undefined at the corner. And I mean, how would you prove that? Well, here is right there in part D, that's f prime of 0. This should look familiar. When we first learned what the derivative was, being the slope of the secant line between 2 points pushed incredibly close together, that's what that does. Well, that would be f prime 0. Why do I have to do it this way? Well, I don't have a formula. I mean, we never learned a rule to find the derivative of absolute value. So I guess to prove it, that there's your proof of what our f prime 0 is. Okay. Now, so here goes. In order to do that limit, I need to do this one, which is from the right, and this one from the left. And if those are different, that means this one doesn't have an answer. So let's see. Okay. Let's do this. Let's say limit h goes to 0 from the right. All right. What's f of 0 plus h? Well, that's what we write because that's what the original thing we learned said. F of x plus h minus f of x, all that. But isn't this just f of h? 0 plus h is h. Okay. If h goes to 0 from the right, then h is positive, and into that function, we're in this case, and we get that. So if h goes to 0 from the right, f of h is h. In other words, what if you put, what's an example of a number close to 0 from the right? I don't know, 0.5? What if you put 0.5 into this function? Which one of these does it satisfy? The top one. And where do you put it there? 0.5. That's your answer. So it's like I'm treating the h like that. H is barely to the right of 0. Put it into this function. Put it there. That's what you get. Okay? All right. Now, minus f of 0. Well, what do you get when you put 0 in? Get 0. Okay? Over h. And what's this? Well, h minus 0, it's h over h. It's 1. 1 is h is still 1, so 1. All right, there's that limit. What about the other one? What if h goes to 0 from the left? All right, so here goes. Limit h goes to 0 from the left. If h goes to 0 from the left, that being f of h, well, h is a negative number. It fits this condition. It goes there. Okay, so negative h. Okay, minus f of 0. 0 over h. All right, how's that reduced? Negative h minus 0. Negative h. Negative h over h. Negative 1. To apply the limit, negative 1. All right. Now, okay, if that looks strange, what do you do? Okay, what these are doing is like saying from some starting point of 0, I'll take some point to the right of it over here. I'll find the rise over the run, and I'll push those points together. Well, if you did that, what's the slope from here to any place out there? It's 1. From the left, okay, start at 0. Go to there. It says from the left, okay, so go to there. What's the slope of the line to those points? Even if you push them together, negative 1 the whole time. Yeah, that's all that means. So like from the corner, extrapolate to the right, slope's going to be 1 no matter how or where you go out there. From the left, slope's going to be negative 1. All right, okay, so I did that. Showed you the curve, that's what it tells us. But what does it say about this limit? Well, if any limit, was different on one side versus the other, then the limit itself wouldn't exist. That's something we talked about when we started learning limits, okay? So, all right, see that? That's exactly the same thing as this. Is going to 0. From one side you get this. From the other side you get a totally different number. So that limit is dne because those are different. Conclusion, all right, f prime of 0 doesn't have an answer. I guess so we'll say undefined. Yeah, because if you went from there to the right versus the left, you would get disagreement about what the slope was between your chosen points. That's all that means, okay? All right, so there, we got most of 1 to do that. Now, part E says, well, just what is f prime of x then? Okay, well, going any point to the right, we'll find that the slope is 1. To the left, no matter where you are, it's negative 1. Right there in the middle at the corner, it's undefined, so, well, that's kind of like the ones we did earlier. Here goes. F prime of x is negative 1 if x is less than 0. Positive 1 if x is greater than 0. Anything else? No. I mean, should we include 0? No, because f prime 0 doesn't have an answer. It needs to be left out of our definition, okay? So just notice that that has to be contained in this information, all right? Okay, so well, that's one's probably got to be the hardest one in the whole lesson. Well, 1 and 2, okay? Two's the same thing, but say we did 1, let's just do another one, make sure we see how it works, okay? So I give you some original curve again that is in terms of absolute value, and therefore we really don't have any formula to calculate its derivative. I would like to prove that the slope at the corner there is undefined in the same manner. Okay? All right, so it's same series questions. Regarding this, can you write it as a piecewise function? Okay, so let's see. Piecewise, like pieces. If you took the pieces of this, would there be any kind of predictability or order to it? Well, all right, look at that. That piece is a line in and of itself. And let's say I took enough algebra in the past, and if I have 2 points on a line, I can find its equation. This one is y is equal to 1 minus x. Okay, just that piece, like from here down forever that way. All right, and over here, all right, that is a different line. Obviously, it's different. And I know it goes through this point, and I know it goes through that point, and I can think back to algebra like I was saying, and this is y is 1 plus x. Okay, that is, a matter of fact, the equation of that line. And then this one's different. Okay, now that would do it then. Here's how this thing reduces to pieces. It's 2 lines. We get y is equal to 1 plus x if x is less than 0. Y is 1 minus x if x is more than 0. Should we include 0? Well, this is supposed to capture this. What if you put 0 into this? You get 1. Yeah, we should include, it needs to say that. If I include 0 here, it will give me 1. If I include it here, it doesn't matter, I guess. I don't know, just put it there. Yeah, so does this get you all the same x's and y's as that one? Yeah, same thing. That's all I was trying to do. But it breaks it down to pieces. That's the only difference. Okay, now B says, like, with the help of that, can you find this limit? Limit h goes to 0 from the right, f of, that whole thing. What's that do? It says take f of 0, which is this point, take some point on the curve to the right of it, over there somewhere, find the slope between them, push them together. What's the slope over here, basically? From this point to any point on that, what's the slope? All right, now we're going to do the math on that. I mean, what do you think it is? It looks like it's -1, but here, let's prove it. Let's do the math. That is just f of h, right? And say you put into this function a positive number, something barely to the right of 0. Which one of these? That one. Okay, so we get, if we put h in, and h is a positive number, that's what we're plugging in, we get 1 minus h. Okay. All right. And what's f of 0? Well, f of 0 is 1. F of 0, however you do it, 1. H. I forgot. Limit. H goes to 0 from the right. Okay. What's that reduced to? 1 minus 1 is nothing. Then negative h over h is -1. -1. Well, what does it look like the slope is? From here to some spot on the curve to the right? -1. All right, I'm not surprised about that. That's all I'm saying. Okay, now from the left, so we got, again, what's this? F of h. What would the function give you if you plugged in a negative number? Okay, well, here's the function. Negative numbers go into that. So say I put f of h, I put h in. H is some negative number. I'll get 1 plus h. So I get limit. H goes to 0 from the left. 1 plus h, that's what that function is going to give me if I put that negative number in right here. 1 plus h minus f of 0. F of 0 is 1 over h. How's this reduce? 1 minus 1 is nothing. H over h is 1. Apply the limit. you get 1. Okay, does that make sense, or does it at least seem right? Take 0 on the curve. Take some point to the left of it. Find the rise over run. I see a line that has a slope of 1, and that's what it tells me. Okay. All right, now, so here's our proof that the derivative is undefined at 0. 0 is a corner. To do this limit, for it to have an answer, the same limit from the right and the left have to agree, and they don't. So there's no agreement about what actually happens at that point. There's no answer. It's undefined. So this would technically be D and E because, well, those are different. Hence, this limit does not have an answer. But let's, you know how we say it. We'll say f prime 0, undefined. There is no way to measure the slope at the corner, because if two lines of different slopes meet there, then at that spot there isn't a slope. We're not getting agreement on either side. Okay, so f prime 0, undefined. Answer, well, why is that? Because -1 is not the same thing as 1. If those were the same number, there would be an answer, but they're not. Okay? All right, so what is the derivative then? Last part. Well, the derivative is undefined at 0. Otherwise, I would say this. If you're anywhere over here, the slope is 1. That's what this number means. Over here, it's -1. At the corner, there is no slope. So I'll say -1 if x is greater than 0. 1 if x is less than 0. That's the information about what happens over there. Okay. Should we include 0? Oh no. F prime 0 is undefined. You better leave it out because there isn't an answer to it. There is no slope at 0. It's not part of my definition over here. It doesn't give me the information. Okay. All right, now, so that is all the ones I wanted to show you from that lesson. Or let's see. Okay, so one more. So I'm going to look at this point, I'm looking at, in lesson 9, question 3, okay? Where I wanted to have an example where we actually see this, okay? The derivative is undefined because the curve is vertical. All right, just want to see if we could notice that if we ever had it, all right? So in 3a, it's like two curves are given, and we're just trying to tell them apart. It says the first curve, third root of x. Second curve, x to the 2/3 power. Okay? All right. And question says, which curve has f prime 0 to be undefined? Okay? All right, so which curves, one or the other, or maybe both, which curve has f prime 0 to be undefined? And then maybe y. All right? Okay, so say we start there. Those are the curves. To do the math, I don't know. We need to tell them apart. I called them both f on the lesson, but let's say f1 and f2, okay? So f1 prime, the derivative of this first one, that's x to the 1/3 power. And so I'll get 1/3 x, and then I got to subtract minus 2/3. Okay? Or you could say that was 1/3 x to the 2/3 power. There's your derivative of that first one. The other one, f2 prime. Okay? There's going to be 2/3 x, 2/3 minus 1, negative 1/3. Okay, in other words, 2/3x to the 1/3. So there's your derivatives. Now, to get things going, it says, which curve has f prime 0 to be undefined? Well, both of them. I mean, if those are the derivatives and if those are the formulas that calculate the slope of the curve, neither of them gives an answer when you put 0 in. Okay, so which curve has f prime 0 to be undefined? Short answer is both of them. Okay, look at them. All right. Now, okay, so they both have f prime 0 to be undefined, but what could that mean? Corner point, the curve is vertical, it has a discontinuity. I mean, how do we tell which one of these it is? Okay. Well, in the lesson, it says if the derivative limit at 0 is infinity from either direction, then the slope of the curve there is vertical. All right? It's there in the lesson. So I'm trying to say, like, which one of these gives you infinity from both directions, okay? And it's that one right there, okay? All right, so for B, the way the question stated in the lesson, which curve has a vertical tangent at 0? Let's say this, f1x, being the third root of x, has a vertical tangent at x is equal to 0. Here's the reason. The derivative tells me the slope of the curve. If the derivative, being the slope, goes to infinity at this point from either direction, well, an infinite slope, that's like saying it's vertical. Okay? All right, so let's say this. The limit as x goes to 0 from the right of f1 prime is equal to the limit as x goes to 0 from the left of f1 prime. And they're both positive infinity. Okay? It's like saying that as you go there on the curve, the slope becomes bigger and bigger and bigger and bigger. And it just means it gets steeper and steeper and steeper before it becomes vertical. All right? Okay, why not this one? Well, because with the 1/3 power, negative numbers are going to give you a negative infinity, and the positives are going to give you positive infinity. And like we would need these to both be infinity or both be negative infinity. It says it in the lesson. It's there at the top. All right, that's the way it's got to be. This one doesn't do that, but x to the 2/3 power does. Well, why is that? Well, what is x to the 2/3 power? 3 times, say, third root of x squared. That's what the 2/3 power is. So if you imagine like very tiny positive numbers in there, you'll get in that a very small positive number, really big answer. With the negatives, what's the third root of a negative? That's negative. What if you square it? That's positive. Okay, so all right, y prime will shoot to infinity right there as you go to 0 from the right or the left. Infinity in either case. If from the left it was infinity and the right negative, well, they don't agree. A vertical tangent would only happen if both of these give you the same infinity, either positive in both cases or negative infinity in both cases. Now, the other one won't do that, as mentioned. So it's that first curve that has a vertical tangent. It's not the second one.